Hey everyone, welcome to Future Forward. I'm Rowan, and with me, as always, is my incredibly curious co host, Alex.
Hi, everyone. I'm already getting goosebumps about today's topic.
Well, you should be. Today, we're diving into something that sounds like pure science fiction, but it's actually based on real scientific projections. We're talking about what it means to be human in the 22nd century.
Wait, you mean like 100 years from now? That feels so far away, but also weirdly close when you think about it.
Exactly. Imagine waking up in a world where you can't tell where human consciousness ends and artificial intelligence begins, where the very definition of being human has completely transformed.
That's both fascinating and slightly terrifying. Are we really heading in that direction?
According to experts, we're actually moving toward this future faster than anyone predicted. You know what's really mind-bending? The change we're about to go through is being compared to the leap from single-cell organisms to complex life.
Wow, that's quite a comparison. So, what exactly are we covering today?
We'll explore everything from merging with AI to colonizing Mars and how these changes might reshape society, consciousness, and what it means to be human. Ready to peek into our possible future?
Lead the way. I have so many questions already.
Let's start by looking at the building blocks that are making this future possible. You know how we often talk about technology advancing quickly? Well, what's happening now is unlike anything we've seen before.
I'm guessing you're talking about more than just faster phones and better Wi Fi?
Oh, way more. Think about this. Right now, scientists have already mapped individual neurons firing in real time. We can literally watch thoughts forming in the brain.
Wait, really? How do they even do that?
They use something called high-resolution brain imaging combined with machine learning. But here's what's really interesting. We're not just watching anymore. We're starting to interact with these neural patterns.
You mean like controlling things with our minds?
Exactly. Companies like Neuralink have already demonstrated direct brain-to-computer communication. And that's just the beginning. Remember, quantum computing, it's not just theoretical anymore.
Refresh my memory. What makes quantum computers so special?
So traditional computers process information in ones and zeros, but quantum computers use something called qubits, which can exist in multiple states at once. It's like going from seeing in black and white to suddenly having access to every color imaginable.
That sounds incredible, but how does this connect to human enhancement?
Well, these quantum systems are becoming powerful enough to model complex biological processes. We're talking about simulating entire neural networks, understanding protein folding, even predicting how genetic modifications might affect us before we make them.
So we're using super powerful computers to understand ourselves better?
Precisely. And here's where it gets really interesting. Remember Ray Kurzweil? He's that futurist who's been surprisingly accurate with his predictions about technological advancement.
Oh yeah, wasn't he the one who predicted smartphones and wireless internet way back in the 1990s?
That's him. Well, he's projected that by the 2030s we'll have the computational power to simulate the entire human brain. And looking at the progress we're making with quantum computing, he might actually be conservative in that estimate.
That's incredible, but also kind of scary. I mean, if we can simulate a brain, what does that mean for consciousness, for who we are?
That's exactly the kind of question we need to be asking. But before we dive into the philosophical implications, let me share something even more immediate. Scientists have already successfully created brain organoids, tiny lab-grown brain tissue that actually produces brainwaves.
Hold on. You're telling me we're growing actual brain tissue in labs?
Yes. And while these organoids are very primitive compared to a human brain, they're teaching us incredible things about neural development and how our brains actually work.
I'm trying to wrap my head around this. So we've got quantum computers, brain-computer interfaces, and lab-grown brain tissue. It's like all these separate technologies are converging.
That's exactly what's happening. And there's one more piece to this puzzle: genetic engineering. With CRISPR technology, we can now edit genes with incredible precision.
I've heard about CRISPR. Isn't it already being used in medical treatments?
Yes, and the results have been remarkable. We've already seen successful treatments for certain genetic disorders, but what's really fascinating is how these technologies are starting to work together.
What do you mean?
Imagine combining precise genetic engineering with brain-computer interfaces, all guided by quantum computer simulations. We're not just treating diseases anymore. We're starting to enhance human capabilities in ways that were pure science fiction just a few years ago.
Wow, I mean, the possibilities seem endless. But surely there must be risks and challenges.
Oh, absolutely. And that's exactly what we need to talk about next. The technical foundations are incredible, but they raise some serious questions about safety, ethics, and who gets access to these technologies. All these technological advances we've been discussing, they're not just changing what we can do, they're completely reshaping our economic future.
In what way? I mean, we've had technological revolutions before, right?
True, but this is different. Think about it. When 60% of human activities become AI augmented, which is what current statistical models are predicting, we're looking at a fundamental shift in how our economy works.
60%? That's that's a lot more than I expected. But wouldn't that just mean more unemployment?
That's where it gets interesting. Traditional economists are actually having heated debates with advocates of something called post-scarcity economics. It's not about losing jobs, it's about redefining what work means entirely.
Post-scarcity? That sounds like something from Star Trek where they don't need money anymore.
You're not far off. But here's what's fascinating. We're already seeing early signs of this transition. When you combine enhanced human capabilities with advanced AI and automation, you create abundance in ways we've never seen before.
But surely we can't create unlimited resources. There have to be limits.
Well, that's where human enhancement comes into play. Enhanced cognitive abilities mean we can solve complex problems more efficiently. Imagine scientists with augmented intelligence working on sustainable energy, or architects designing self-repairing buildings.
So we're not just talking about robots taking over manufacturing?
Not at all. Current trends show we're moving toward what economists call a hybrid economy. Humans with enhanced capabilities working alongside AI systems, creating solutions we can't even imagine yet.
But what happens to regular jobs? To people who can't access these enhancements?
That's actually one of the biggest challenges we're facing. The models show that without proper planning, we could see the biggest wealth gap in human history. But there's also potential for the opposite.
What do you mean?
Some economists are suggesting that as production becomes more automated and efficient, the cost of basic goods and services could drop dramatically. We're already seeing early signs with things like information and entertainment.
Oh, right. Like how we can access almost any information or learn almost anything online for free now.
Exactly. Now imagine that principle applied to everything from housing to healthcare. The real debate isn't about whether this change is coming, it's about how we manage the transition.
That sounds great in theory, but aren't we still dealing with resource limitations?
Yes, but enhanced human capabilities are changing that too. We're seeing breakthroughs in resource management and recycling that seemed impossible just a few years ago. Some projections suggest we could achieve 90% resource efficiency by 2100.
90%? That's incredible. But what about things like food production?
Current trends in vertical farming combined with genetic engineering are showing promising results. We're looking at potential yields 10 times higher than traditional farming, using just a fraction of the resources.
So we're talking about solving scarcity through technology and human enhancement?
That's part of it. But there's also a fundamental shift in how we think about value and wealth. When basic needs are met through automation and enhanced productivity, we might see a complete restructuring of what we consider valuable.
Like what?
Well, imagine a world where creative expression, innovation, and human connection become the new currency. Where your contribution to society isn't measured by how many hours you work, but by the impact you make.
That's actually pretty inspiring, but also kind of overwhelming. How do we prepare for such a massive change?
That's exactly what economists and policymakers are grappling with right now. The transition won't be easy, but the potential benefits are enormous. We're talking about a world where economic anxiety could become a thing of the past.
It almost sounds too good to be true.
Well, like any major transition, it comes with its own set of challenges. And that's actually what we need to discuss next, the potential pitfalls and how we might avoid them. All this talk about enhancement and economic shifts brings us to probably the most heated debate of our time, the transhumanist question.
Transhumanist, that's about using technology to enhance human capabilities, right?
Exactly. And right now, we're seeing an intense philosophical divide between what are being called bioconservatives and transhumanists. It's fascinating because both sides actually want what's best for humanity. They just deeply disagree about what that means.
I can imagine. I mean, we're talking about fundamentally changing what it means to be human.
Precisely. The bioconservatives argue that there's something sacred about our natural human state. They point to examples where rapid technological change has had unintended consequences, like how social media was supposed to connect us, but often ended up dividing us.
That's actually a pretty good point. We don't always see the downsides until it's too late.
True. But here's where it gets interesting. Transhumanists argue that we've always been changing and enhancing ourselves. From the first time we used tools to the invention of writing, these were all forms of human enhancement.
Oh, wow. I never thought about it that way. Even wearing glasses is technically human enhancement, right?
Yes, and that's where the debate gets really nuanced. Because where do we draw the line? Is a pacemaker okay but not a neural implant? Is corrective gene therapy acceptable but not cognitive enhancement?
Those are tough questions. Are there any real-world examples we can look at?
Actually, yes. Take the case of Olympic athletes. We already have strict rules about what kinds of enhancements are allowed. But now we're seeing proposals for a separate category for enhanced athletes.
Wait, like a separate Olympics for people with technological enhancements?
Exactly. And it raises fascinating questions. If someone has a prosthetic leg that actually performs better than a biological one, is that an unfair advantage? Or is it just the next step in human evolution?
I suppose it depends on how you define fair, but what about more extreme enhancements?
That's where the ethical debate gets really interesting. Some philosophers argue that we have a moral obligation to enhance ourselves if it means we can solve global problems more effectively.
A moral obligation? That's a pretty strong stance.
It is. Their argument is that if we could enhance our intelligence and empathy in ways that help us solve climate change or prevent wars, wouldn't we be morally obligated to do so?
But couldn't that create even bigger divisions between enhanced and unenhanced people?
That's one of the biggest concerns. Some ethicists are warning about what they call cognitive apartheid, a world where enhanced humans become so different that they essentially become a separate species.
That sounds terrifying. Are there any proposed solutions?
Several, actually. One interesting approach is the idea of democratic transhumanism, ensuring that enhancements are distributed equitably and regulated through democratic processes.
Like making sure everyone has access, not just the wealthy?
Exactly. But there's another fascinating aspect to this debate, the question of identity and consciousness. If we enhance our brains, are we still the same person?
That's actually kind of scary to think about. How do we even begin to answer that?
Well, some researchers are studying people who've already received neural implants for medical conditions. They're finding that while these people's capabilities change, their core sense of self usually remains intact.
That's reassuring, I think.
It is, but it also raises new questions. As these technologies become more sophisticated, we might need to develop entirely new frameworks for thinking about identity and consciousness.
It sounds like we're really at a crossroads here.
We absolutely are. And what makes it even more complex is that while we're having these philosophical debates, the technology keeps advancing. We might need to make some of these decisions sooner than we think. You know, there's another fascinating aspect to human enhancement we haven't touched on yet: space colonization. When we talk about becoming multiplanetary species, we're not just talking about building ships and habitats.
What do you mean? Isn't getting to Mars primarily an engineering challenge?
That's what people used to think. But now we're realizing that the human body itself might be our biggest limitation. Living on Mars or in space stations means dealing with radiation, lower gravity, and completely different atmospheric conditions.
Oh, right. I've heard that astronauts can lose bone density in space.
Exactly. And that's just the beginning. Current research shows that extended space travel affects everything from our immune systems to our eyesight. Some scientists are suggesting that true space colonization might require us to enhance ourselves biologically.
Wait, so we'd need to change our actual bodies to live on Mars?
The evidence is pointing that way. Think about it. Mars has about 38% of Earth's gravity. Its atmosphere is mostly carbon dioxide, and the radiation exposure is significantly higher than on Earth.
What kind of changes are we talking about?
Well, some researchers are already exploring genetic modifications that could help humans better handle radiation. There's also work being done on enhancing our ability to process carbon dioxide more efficiently.
That sounds like we'd be creating a new subspecies of humans specifically adapted for Mars.
You're not far off. Some evolutionary biologists predict that within just a few generations, Mars colonists would naturally start developing different physical characteristics from Earth humans.
Wouldn't that mean Mars humans and Earth humans might eventually become incompatible?
That's actually a major point of discussion in the scientific community. Without some form of controlled enhancement, natural evolution in different gravity and atmospheric conditions could lead to exactly that.
So we might need to deliberately guide our own evolution to stay, well, human?
It's a fascinating paradox, isn't it? We might need to enhance ourselves to remain recognizably human in these new environments. Current projections suggest the first generation of Mars-born humans could face significant health challenges without some form of enhancement.
What kind of timeline are we looking at for all this?
Well, the first permanent Mars settlements are planned for the 2040s. But here's what's really interesting. The technology for human enhancement might actually be ready before our Mars infrastructure is.
Really? So we could have Mars-ready humans before we have a Mars-ready Mars?
Exactly. And it's not just Mars. There's serious research being done on adaptations for long term space station living, asteroid mining, even potential settlements on Europa or Titan.
Those are Jupiter's moons, right? Wouldn't those environments be even more challenging than Mars?
Much more challenging. The radiation levels around Jupiter are intense, but that's driving some fascinating research into radiation resistant DNA modifications. Some scientists are even studying tardigrade genes to understand how they survive in space.
Tardigrades? Those are those microscopic water bears that can survive almost anything, right?
Right. And understanding how they do it might be key to our own space adaptation. But there's another aspect to this that often gets overlooked: psychological adaptation.
Oh, I hadn't thought about that. I guess being so far from Earth would be pretty intense psychologically.
Absolutely. Some researchers are suggesting we might need to enhance our mental resilience and emotional stability just as much as our physical capabilities. Imagine being months or years away from Earth in an environment where one small mistake could be fatal.
That's a lot of pressure, both physically and mentally.
It is. But here's what's really fascinating. These space-related enhancements might end up benefiting Earth-bound humans too. Imagine having radiation-resistant cells, or better oxygen processing efficiency, or enhanced emotional stability.
So space colonization might actually drive human enhancement for everyone?
That's what many experts are predicting. It's like space exploration is giving us a preview of human evolution's next chapter. You know what fascinates me most about all these changes we've discussed? It's not just about enhancing our bodies or extending our lifespans. It's about fundamentally transforming human consciousness itself.
What do you mean by transforming consciousness? That sounds almost mystical.
Well, think about how our consciousness has already been changed by technology. Remember what it was like before you had instant access to all human knowledge through your phone?
I guess I do think differently now. Like my memory works differently because I know I can look things up.
Exactly. And that's just from carrying a device. Now imagine when these enhancements are actually integrated into our brains. Current neuroscience research suggests we're approaching what they call expanded consciousness.
Expanded consciousness? That sounds intense. What exactly would that mean?
So here's where it gets really interesting. Scientists are finding that our brain's capacity for new neural pathways is far greater than we thought. When we add brain-computer interfaces to the mix, we might be able to experience consciousness in completely new ways.
Like what? Give me an example.
Well, imagine being able to process multiple streams of thought simultaneously, or being able to directly share your sensory experiences with someone else. Not just describing what you see, but letting them actually see through your eyes.
That's... wow. But would we still be us? Would we still feel human?
That's the big question neuroscientists are grappling with. Some research suggests our sense of self is more flexible than we thought. People who've experienced brain-computer interfaces often report feeling that the technology becomes part of their identity.
Sort of like how we feel our clothes are part of us, or how a blind person's cane becomes an extension of their body.
Yes. And here's something even more fascinating. Some researchers are predicting we might develop what they call distributed consciousness.
What's distributed consciousness?
Think of it like this. Right now, your consciousness is limited to your brain. But what if it could extend beyond that? What if you could temporarily merge your consciousness with an AI system to solve complex problems, then return to your normal state?
That sounds like science fiction, but I guess a lot of what we've discussed today would have sounded like science fiction not too long ago.
Exactly. And here's what's really intriguing. Some consciousness researchers are suggesting that this expansion of human consciousness might help us understand consciousness itself better.
You mean like finally figuring out why we're conscious in the first place?
Yes. By studying how consciousness changes as we enhance and expand it, we might finally crack some of the fundamental mysteries about how consciousness works.
But couldn't this also go wrong? I mean, what if we lose something essential about being human in the process?
That's a crucial concern. Some researchers are advocating for what they call conscious enhancement, making sure we preserve and amplify what makes us uniquely human while we expand our capabilities.
Like keeping our emotions and creativity while adding new abilities?
Precisely. The goal isn't to become cold, calculating machines, but to become more deeply human, more empathetic, more understanding, more connected to each other and our environment.
That's actually beautiful, and a bit less scary than I thought.
It is beautiful. And you know what's really promising? Early studies with neural interfaces are showing that enhanced consciousness often leads to increased empathy and emotional understanding, not less.
Really? How does that work?
It seems that when we expand our consciousness, we also expand our capacity to understand and feel for others. It's like upgrading our emotional hardware along with our cognitive abilities.
So we might end up being not just smarter, but kinder too.
That's what the research is suggesting. And maybe that's the most important enhancement of all, the ability to understand each other better, to feel more deeply, to be more fully human. You know what strikes me most after exploring all this? We're not just talking about changing what humans can do, we're talking about a transformation as profound as the leap from single cell organisms to complex life.
It's mind boggling when you put it that way. And it's happening so much faster than anyone predicted.
That's what makes this moment in history so crucial. We're standing at a crossroads where the decisions we make about human enhancement, consciousness expansion, and space colonization will shape not just our future, but potentially the future of consciousness itself in our universe.
When you think about it, we're really the bridge generation, aren't we? We're the ones who will help decide how this transformation happens.
Exactly. And while the challenges are enormous, what really gives me hope is how these technologies seem to be pushing us toward not just greater capability, but greater understanding and empathy.
That's actually pretty inspiring. Instead of losing our humanity, we might actually become more deeply human.
And that might be the most important insight of all. The 22nd century human won't just be enhanced physically or cognitively, they might be better equipped to tackle the fundamental challenges we face as a species.
So maybe the real question isn't whether we'll remain human, but what kind of humans we want to become.
Precisely. And that's what makes this such an exciting time to be alive. We're not just witnesses to this transformation, we're active participants in shaping humanity's next chapter.